everybody, to this webinar on Is MTTR Dead? My name is Dan Ruby. I'm the VP of Marketing at Noble 9. I'll be moderating. I'm joined by some outstanding guests. We have Sasha. I'm so worried about mispronouncing your last name, and then I called you Sasha. Oh my God. Sasha Cherchevsky.
Almost. You almost got it. It's fine.
Yeah. We've got Dan Salinas, we've got Alex Hidalgo, and we have Casey Rosenthal, all outstanding minds in reliability, SRE. And we're gonna kick this off because MTTR is kind of a hot topic in the reliability world. And like if you've read Alex's book on SLOs, correct me if I'm wrong, Alex, that the entire last chapter is basically you stomping all over MTTR as a metric.
Yeah, and the funny part is I didn't even realize that's what was going to happen. It was a chapter that kind of flowed out as opposed to having an outline. And as I was writing it, I'm like, oh shit, some people are going to not like this chapter. And I didn't expect the reliability reporting chapter to potentially be the most controversial in the book. But like here we are.
So I'm going to start with a stupid but necessary question. What does the R in MTTR stand for?
Most commonly remediation.
Most commonly remediation. Okay. I mean, that's kind of part of the issue is nobody really knows, it kind of varies from organization to organization. Does it mean time to response? Does it mean time to remediation?
Or recovery.
Or recovery.
Or resolution. Or, right? Like there's half a dozen R's alone, much less the other things we slot in after the letters MTT. And that's definitely part of the problem, right? Like we can't even, as an industry, agree on what that R actually means.
I would argue it doesn't matter because they all suck. So,
well,
counterpoint.
So I think the definitions. So like it applies to all the metrics, right? Like any metric you pick, if you don't have a good operational definition for the metric, and if you don't agree with other people on what the metric actually means, you're not going to get good results, right? And that, like we were talking about the industry, but that sometimes happens inside the organization, right? When we're comparing apples to oranges inside the same organization and getting different results and giving people different KPIs.
Yeah, like I think that's correct, right? Like, we'll have plenty of time to dissect whether or not we think that these kind of metrics are reasonable or not, but the exact definition, as long as your organization all agrees on what that R means, then like that's probably fine.
Yeah. So that aside, why does MTTR suck? Let's start with Sasha.
So see, I don't want you to start with me because I want to hear from Alex and then see, because I think one of the interesting things about this webinar is that we're all sort of on the same side that MTTR is not great, right? And I think it's also like best to it's important to say that MTTR is just another metric, and all metrics are flawed, and all metrics are imperfect, and all metrics can be gamed. And so, like, if you're measuring MTTR, it's not necessarily that you're doing something wrong. It's just that potentially you could be doing something better.
Okay, so I will take your bait, Sasha. I would go so far as to say if you're measuring MTTR, you at best you are wasting your time, which is to say that you are doing something wrong. So there's half a dozen reasons. I could start with my top three. The first is it's the wrong statistic. We have enough data to show that people's time to resolution does not follow a normal curve. So, to get all the statisticians out there excited, mean only has meaning if you're dealing with a normalized curve. And we know that nobody's curve is normalized. So, I can give you examples mathematically of cases where the MTTR decreases, but overall resolution time increases, right? A fatter tail.
Mhm.
So it's just mathematically wrong. The second reason it's a bad idea, it doesn't correlate with severity. So the criticality of an outage does not correspond with how long the outage lasts. You could have a very long outage that customers don't notice.
Mhm.
So it doesn't give you any business relevant information. The third, we've seen that in order for a statistic like MTTR to be statistically significant, if you were using the right model, which you aren't, you would need more data on outages than Google has. And chances are extremely likely that you do not have more data than Google has about your outages. So, you just start with like what you think you're measuring with MTTR is mathematically wrong.
So I think, like, since I've decided to be the devil's advocate for MTTR on this show, I think one of the biggest problems with MTTR, and there's a number of problems with MTTR, but one of the biggest ones is that we lump in together things that are different, right? So not just the operational definition is like what does the mean time to what, right? But also what kind of incident, because you can have different kinds of incidents. But I think so. We were talking prior to this is that like, oh well, software incidents are not like hardware incidents, they're all different. I think it's a little bit presumptuous. I think there are kinds of software incidents that are the same, right? Like you can have the same type of failure occur over and over and over again, and if you zoomed in correctly into that type of failure and you measure statistics about that type of failure, you could actually have meaningful learnings about whether or not you're improving or not. But if you're lumping like a critical business outage with a network blip that nobody noticed, then yeah, of course you're not going to learn anything interesting.
But like I will disagree a little bit there, right? Like I think incidents are inherently unique, right? So you might say something like the same type of failure occurs, but that's indicative of the failure and doesn't really capture the incident, because any time that someone gets paged or someone notices something, right? Like however you want to define within your own organization what constitutes, like an incident, in the very least, the human responding is different because they exist at a different time, right? Even if the exact same triggering factor is able to be identified, I'm still a different person as a responding engineer if I'm sitting at my computer at 2 p.m. Versus being woken up at 3 a.m. versus it being a different responder, right? So, there's so many other components to what we generally consider an incident, all the human factors, if you will, that, I'd argue they necessarily always are unique. And because they always are unique, even if you want to think, oh, this is similar to this other one, well, it's only similar. It's not actually the same, and therefore, as you mentioned, you are comparing apples to oranges.
If you think about like MTT, forget the R, those things kind of came out of manufacturing, where inherently a manufacturing process, the stamping of a part or whatever is a very consistent process with a very, to leverage Casey's point, like focused on low standard deviation things. And to Alex's point, if you have something with a high standard deviation, the mean does not mean much, right?
Means are not often meaningful. But yeah, I do think that's a good point by Dan is we jumped right into this, I think, because we all care a lot. But just to be clear for everyone that's joined the webinar, right? Like we're talking very specifically about does MTTX, right? Mean time measurements, do they tell you anything useful about complex computer system incidents, right? it is, in fact, a very statistically useful thing, for example, hard drive failure rates or things like that, right? Just want to make sure that that's at least covered, you know. It's not that we're saying, or at least I'm not saying, I don't want to put words in anyone's mouth. I'm certainly not saying that every single attempt at using a mean time to failure, for example, is necessarily bad, because it often is very good math, again, for hardware, you know, things like that. It just doesn't present the same way in how complex distributed systems fail.
So that's, I want to take things a little higher level, because a lot of times when, you know, I'm a marketer. When I hear something like mean time to recovery, as a non-engineer, it makes sense, because outages are terrible for my business, and I want to know how long it takes us to fix them. So MTTR, MTTX kind of is this, for better or worse, gold standard on, if something goes wrong, how long does it take to fix it? But if it's, you know, statistically and mathematically incorrect, you know, how do you go about expressing well, I guess two questions. One, why does management seem to focus so heavily on MTTR? And two, how do you express to them that A, it's a bunk metric, and B, I've got a better way of expressing, you know, what you're asking?
So I want to say something that is like the second and much bigger problem with MTTR is it's used as a target metric. And not every metric in the world is a target metric. Some measurements are useful for learning, but they should not be a target. And if you make them a target, they create problems, right? So if your OKRs or KPIs or whatever are tied to how well your MTTR is improving, you definitely are not going to get good results, right? Because like all metrics are gameable, so like people will game the MTTR and whatever. And in all of these examples that we had before, you can have MTTR improvements or deterioration without any actual correlation to how well your company is doing and how impactful the outages are, right? And also, like, just the fact that you improve from one quarter to the next does not necessarily mean that you improved resiliency. So it's a bad metric as a target. It's especially a bad metric to measure engineers on.
I agree with that. And to bring that back to your question, Daniel, actually, no, I'm going to avoid your question again and go a step higher. Because I think the way that we got here, Alex already mentioned, right? The reason executives look at this number is because we borrowed it from hardware manufacturing, where it's relevant, where it makes sense, where things actually do fail along a normally distributed curve. That's how we got here. There's a parallel universe where we didn't do that, and we think about reliability of systems in better ways. But to underline why this is so important, and I don't know how many people are going to watch this webinar after it's published, but when you have outages like the CrowdStrike, the recent CrowdStrike outage, and you know, we could list many large critical infrastructure outages behind that one. Here in the United States in particular, it increases calls for federal regulation of uptime and software engineering. And if we don't get this right, if we don't put in a better way of discussing reliability and uptime, a more meaningful, a mathematically accurate way, perhaps, then we're going to get regulated, and that's going to be bad for everybody, because the government's going to regulate it the wrong way. They're going to use something like MTTR or nines of uptime or some other metric that is again mathematically inappropriate. And you know, there are sitting senators who have proposed bills that would regulate software engineering as a profession. Now, I don't have a grad degree in comp sci, which means I immediately would lose the ability to work on systems in production, right? And that would greatly increase the income gap in the United States. I don't think any of us want that world. So it's incumbent upon us, SREs in particular, to reclaim the narrative around uptime and give executives a better way to discuss this so that we don't end up, digging the hole deeper.
Yeah, I mean, it is you already see some of this with DORA, not the DevOps DORA, but the EU DORA, which is like a new act that was passed to help measure resilience and reliability of primarily financial, institutional, computer systems, et cetera. But I worked my way through that entire document, and I only understood parts of it, to be honest, because I'm not a lawyer and I'm not super versed in all the EU law. And luckily, it has been left a little bit ambiguous in Europe, right? There aren't, right? Like there's no hard, like you must use MTTR, right? There's no hard, you must do this and measure it in exactly this way. It's more a guidance, but the point is it's happening already, right? There are laws being passed saying you need to be a certain amount reliable because as our software becomes more used and more dependent upon, it becomes commoditized. And once something is a commodity, the government sees it, I think, likely correctly, that it needs to operate in a certain level for people to be able to depend on it. But exactly to Casey's point, what I agree with, we got to make sure that whatever happens in that space happens appropriately and happens in a realistic way, happens in a meaningful way, and happens in a way that isn't based upon faulty math, So definitely think that we need to make sure we stay at the forefront of this conversation, and that we ensure that people realize that there are better ways to think about things than, I mean, it's not just MTTR, right? Like that's the topic of this webinar, and that's where people often end up at. And I think Casey correctly points out, likely borrowed from hardware engineering and things like that. But people generally start with counting incidents. How many did we have last quarter versus how many did we have this quarter? And then they try to improve upon that metric. But I don't know, that doesn't matter if you have 10 incidents that are all 5 minutes long versus one incident that's 3 days long. Clearly counting incidents doesn't work, right? So then people try to attach severity levels to these incidents, and okay, how many sev ones did we have versus sev zeros versus sev fives versus and then, well, that math doesn't work. And then people are like, okay, cool, what about our average time of these incidents, right? And then you end up at MTTX measurements, and hopefully people then realize that that doesn't really work, right? But part of it is not just that it's been borrowed from other industries. Part of it is that it is intuitive, right? Like the real quick story I just told, like it does make sense until you actually do the math, until you actually look at the distribution, right? And when you realize that the distribution is not at all normal, hopefully you can move on and realize that we need to learn from incidents in a better way.
So that being said, people still want to know, if you're talking to executives, if you're talking to a board, they want to know how much time was lost that we could have been making money, and what are you doing to do better at that?
Oh, I love the counterfactuals in that we should have been making. Yeah, I mean so far everybody's drowning and we're describing the water, right? And so we'll get there. But what if we just start like why does this feel like drowning? What do the executives actually want? Right? Like, if I'm SVP of cloud ops at a big telecom company and I see that MTTR has increased, what do I do? Like, it's not even actionable, right? If I see it decreases, what do I do? Am I giving out bonuses? No. Like, in order for me to understand what's going on, I'm still going to have to talk to people about the incidents and the nature of the incidents. So why not just set the bullshit metric aside and start there? What I actually care about is what's the impact of downtime on the business. And the easiest way to start with that is with a qualitative process. If you want to put numbers on it later to make it quantitative, fine. That's easy to do. But there's a near infinite number of qualitative ways that we can assess how does how we operate affect business. That's what the executives actually care about. If anybody actually cares about the number, then they're doing a disservice to their business.
Yeah, totally agreed. Right? Like it's a reset that needs to happen. Right? I just told one story, which is you start counting incidents, you add severity levels, you move on to MTTR, right? You're constantly trying to refine whatever metric you have available to you to understand this concept of uptime or availability, both of which I think are not useful things to talk about at all. Anyway, because you need to reframe them in the way that Casey just mentioned, right? Like what actually matters to your customers, to your users, to the people that depend upon you, right? And that's what reliability really is. And that's why I think it's so important to move the conversation away from uptime and availability to reliability, which is a concept that can capture exactly what Casey just said, right? Are you doing what you need to be doing? Are you operating in a manner that you need to be operating? Because there's so much more to it than being quote unquote up or being quote unquote available, you know? And it's not going to surprise anyone on this call, but that's why I like moving the conversation towards SLOs and error budgets, right? Because a good SLI is a metric that measures, are you doing what you need to be doing, right? Not just, is this service up? Is it responding? Is it available? No, it's a good SLI measures, are you doing what you're supposed to be doing, which then helps you take that qualitative into a quantitative, like measurement, allowing you to set a target against it, and then having an error budget, which you can use over time to, in my opinion, way more accurately actually report on the sentiments of your customers than any kind of counting incidents or MTTX measurement will like ever give you. Is it perfect? No, but it gets you much, much, much closer, and that's the most important part.
So I love making people say the implied parts out loud. So tell me how SLO and an error budget is better than MTTR. And so like one thing you mentioned is moving from availability to reliability, but you could technically do this with MTTR if you wanted to, right? So like what's the difference that you see in those metrics that makes them better?
Because you can capture things across a curve as opposed to it being a binary 1 or 0, right? So an error budget helps you capture all those tiny blips of unreliability that may not be a quote unquote incident, right? An incident almost certainly is defined as something requiring a human response, right? That's why we were talking about severity levels and calculating the MTTX against these things in the first place, right? But not every period of time that you're performing suboptimally for your customers is necessarily going to be an incident. So first, you get to capture those little periods of time where you may not be performing well for people, which is still a period of time that your customers might be upset with you, right? And
So
that's
it's
what you're looking
interesting.
to capture.
I think we're back to definitions, right? So the problem isn't MTTR itself, but the fact that like if you say that an MTTR is a mean time to recovery from an incident, and an incident is something that involves a pager and a human, as opposed to someone not being able to do what they want to do with your application, then of course like we're looking at a different level of unreliability, right? Whereas what I'm talking about is if you were zooming in, and I think you can, again, you can argue that you can do this better with error budgets, but if you were zooming in into the tiny blips, right, and you were looking at kinds of failure that are similar, we wouldn't be that far from a hardware disk failing, right?
Yeah, but you still have to deal with the fact that there's not a distribution for you to take a percentile from that is going to be meaningful for you, right? So an error budget operates over time, and time is the normalizing factor there, right? So it allows you to take all this data over a 28-day period, a 14-day period, whatever it might be, and gain that more accurate understanding of how things are going. Whereas trying to take a percentile, right, the P50, the mean of something that doesn't follow a normal distribution doesn't really accomplish much for you at all. So yes, you could hypothetically say that you could make your P50 analysis of tiny blips of things that don't necessarily trigger a full incident, quote unquote. Could you do all that? Sure, but you're still not going to get as close as normalizing data over time.
I think that the other thing is when you go through the process of defining SLIs and SLOs, you kind of get an agreement between the different groups of what good is, and you're measuring what good is, and then you can use that to make decisions and all sorts of things. Like, Casey was talking about being actionable. It's in context of like whatever business outcome you're looking to get. And then you use error budgets to plan out like, hey, maybe this service needs us to invest some energy into, or maybe we need to use more resources, or conversely, we haven't expired our error budget in forever. Maybe we're spending too much cloud costs on things. So I think they're inherently actionable as well. And the process of going through and defining them, I've seen this through a lot of workshops, is really interesting. Like, what is really important to our customers, and let's measure that. Versus how quickly do you respond to someone calling in and saying the place is on fire?
Which is, I think this is a very, like, two key points that you're making. One is like error budgets can be actionable. That is if you're doing error budgets, right? And we can talk about like who's doing error budgets and whether or not people are actually doing SLOs, like, in the way you're describing, where you bring in a coalition and you agree across teams and what is meaningful to the reliability of an application, or whether or not an engineering team or someone else decides on an SLO, and then when the error budget is blown, people can argue that I didn't sign up for this anyway. Like, like we're just going to keep pushing stuff to production.
Yeah, I wanted to build on what Sasha said, right? Is that the next evolutionary step, right? Doing SLOs and using error budgets, as Dan mentioned as well, it generally also implies a certain amount of agreement that's been reached across hopefully multiple teams or even cross organization, and gives you data that lets you make decisions, right? Like, honestly, even just put yourself in the shoes. Well, random, hypothetical, completely clueless C-level, and you're presented with our MTTF or MTTX or whatever MTT something last quarter was this. What do you do with that data actually, right? Oh, it went up. Okay, is bad. Okay, what OKR do you assign to that? Which team? I guess you can go find out which teams produce those metrics to help you. Right? It's just like it's a mess.
Yeah, it's very easy for me to play the role of a clueless C-level. So I'll go ahead and step in there and say, like, SLIs, SLOs, there's a completely different purpose for those metrics, which is those are to tell engineers, is this system behaving the way I expect the system to behave? And if it's not, you can alert on that, and then the engineer refocuses their attention. MTTR is trying to average across those to give a signal to executives about team or organizational performance. And that's the failure, and there's just no way to fix it. Again, it's not a quality of the metric. It's the fundamental nature of that metric is wrong. And yeah, it's inactionable as well. So as a clueless CEO, obviously, if I see there's leftover error budget, I know that the right answer is you need to be running more chaos experiments. But if MTTR goes up or down, that's, in order for me to understand anything more meaningful about the system, I still have to delve into some other way of understanding the reliability of the organization. So why not just start there? Like how I slipped in the chaos.
Yeah,
I was going to say,
okay.
I wish more C-levels went straight to chaos engineering. I mean, I agree. I just wish it was a little.
One would argue that SLOs are important in chaos engineering tests. Actually, we've been working on that. I will. Maybe there's an argument for mean time to respond. Going back to the R. Like maybe that's a measure of how quickly your fire, your organization responds to problems. Like how quickly did the fire, when the fire started, how quickly did the first person get there?
I
But
would
how long
also
it took to put the fire out is going to be completely dependent on what that fire is.
I would
Yeah, I
also
mean,
posit with high confidence that time to respond is not normally distributed.
Depends on the time.
That
It's
curve
more
probably
normally
looks like
distributed, I
this.
would say, than resolve. But
yeah, I mean, Niall Murphy and Stanza just actually did some analysis of this, of mean time to respond, right? And whether or not response times followed any sort of predictable curve. I found some amount of correlation, but not a super, super strong one, including realizing that there were some outliers. Also, the data is very difficult because different organizations measure things at a different granularity. Are we talking about seconds to respond? Are we talking about minutes to respond? So there are some people looking into that, and I think it could potentially produce a slightly more meaningful number than mean time to recovery. But even so, I'm not sure if that number is actually going to be useful outside of an academic sense, and eventually will only, from my point of view, at least from the reports that I've read, both of the first version, and then it was fixed once people realized some of the time-based granularity was like a little off. But like from the way I read it, like we may produce a vaguely reasonable and useful number there, but it'll only ever be usefully applied in terms of what else we've been talking about, which is how can we now better understand what reliable actually means, right? How can we better understand those factors? Definitely not a good metric to tie to an OKR and say, well, we must reduce this number next, like next month, like next quarter.
That kind of leads into a question we have in the chat, with it being an OKR and having expectations of MTTX metrics changing. So Will asks, what happens when my promotion is dependent on response times?
I mean, I'll gladly.
Generally, you game the metric. That's the answer. But again, I wholeheartedly believe that all metrics can be gamed, right? There are just some metrics that are inherently like super bad. Like, if you measure lines of code, you're not gonna get any good outcomes for that. But there are like most good metrics can also be gamed, and it can also become a problem if they're unbalanced with other stuff and they become a target, right? Like it's always, there's always this play that you need to have. Like with SLOs, for instance, you likely don't have just one SLO, right? Like you likely don't have just one metric that you're looking at. And even if you do, like it's usually composite of different things.
I mean, someone at a very, very large financial institution that you've definitely heard of told me just the other day that while they're rolling out their SLO program, that people weren't meeting them, so they just lowered their targets. Like, like they couldn't hit 99%, so they just made all their SLOs 98%, and now their dashboard looks green, and now their leaders are happy, and so yeah, exactly. Everything can always be gamed, and everything can, that can be used, like in the wrong way. But I will kind of side with perhaps what Will is saying, which is if your promo is tied to MTTR, then go ahead and measure it and try to lower it, because go get that money, right? Like go get that promotion. There's nothing wrong with it. As long as you realize you're doing it in order to get your promo, you're not doing it to better understand your systems.
Okay, so we've got a couple of other questions open. Sandra asks, aren't all these metrics a complement to each other? SLIs, error budgets, and MTTR, but on different moments to be used?
I mean, I've been talking a lot, but I have a quick answer from my perspective. SLIs and error budgets are useful data. MTTR, for instance, is always incorrect data. And therefore, I don't think it's actually that there isn't a moment to use mean time measurements for incidents.
Hard same.
Hard same. Okay. Makes sense. We've got a question. How easy or difficult is it to measure SLOs compared to MTTR? And can this be measured for all software applications?
I mean, I don't want to make it the Alex show, but yeah, like I like have an answer here too, which is it is more difficult to measure SLOs because your standard telemetry and your standard telemetry systems may not allow you to do that. Measuring a metric against a threshold and a target percentage is something you can often accomplish, but keeping track of an error budget over time can be difficult, and you need the right systems in place to help you understand your data better. So it is much more difficult to track SLOs than it is to figure out MTTR measurements. That's just simply true. That doesn't mean you can't do it, however, but you may have to write some custom code. You may need to use the right tooling. You may need to find the right vendor to help you do it. But then the second part of that question, can it be measured for all software applications? Yes. And I believe this because SLOs are really just a tech codification of a concept that all humans basically agree upon, which is don't let perfect be the enemy of the good, right? SLOs are really at that level, and this is kind of going away from the MTTR incident discussion. But if you're curious, the actual question, can these be measured for all software applications? Yes, because any software application at some point in time is not going to operate correctly. Just like if you go to a restaurant, sometimes your steak is going to come out wrong, right? They're going to cook it to the wrong temperature. Everything that we experience as humans in life at some point in time will not operate exactly how we expect it to. And we accept that. So we pick the right targets and we try to hit that. And so, again, a little tangential from the incident thing, but that's why I believe, yes, you can measure SLOs for all software applications, regardless. They don't have to be web-based APIs, right? Even a desktop app, I think you can get meaningful data out of by, like an SLO-based approach.
But also, Alex, like you always have an expectation of what an application should do, and that should inform your SLOs. And the other part of it is like that sometimes that discussion actually clarifies what you actually care about or what you think your customers care about. And that's an important discussion in itself, because there's unfortunately a lot of applications where folks don't sort of bother to define what they think the success looks like beyond, responding with 200 okay for a web application.
Yeah, the
totally.
process of
Hard
doing
agree.
Yeah. The process of doing SLOs is really fun to watch because you get different aspects of the business. You get product management, engineering, and SRE together, and they're discussing like what does it mean to be reliable and what is good for our customer. What's the customer journey look like? And that's the fun part. And then they, SLOs is a vehicle for having that conversation for sure. But that's also maybe the tough part because it requires people to talk to each other. Whereas maybe MTTR is sort of like, go to ServiceNow and measure how many sub ones do we have and how long did it take to respond, but I think that's the good part of it. And that's why it's actionable, because people have decided and what good is. And if you don't know what good is, then,
what are you measuring?
I want to sort of bring into something that I'm a little bit conflicted about that Casey was talking about, which is qualitative versus quantitative. And so the problem is we know that qualitative measures are better and they're more informative with regards to a lot of different things like customer satisfaction and like reliability and so on. But qualitative measures are difficult and they take a lot of work and they're not always practical for everyone to implement. And the average C-level executive wants to see something that looks like a pretty dashboard with some math on it. Is there kind of way to reconcile those two things?
I think this is just a matter of us as a community of practice, investigating other ways to build qualitative models. So I mentioned this before, but the go-to model that I recommend for people who don't know where to start is the Kirkpatrick model for determining ROI. I picked that one because it's often used in corporate training, so some executive levels will be familiar with it anyway. But it's just 4 levels. It's not particular. You know, there's no rocket science in there, but the 4 levels increase in difficulty, but also become more meaningful the higher you go. So the first level would be, in the case of incident response, would be ask the people who are responding to the incidents whether or not a treatment or a program like SRE is actually improving the system. And that's easy, right? Like you can just go, quarterly, you could go to the people responding to incidents and give them, a 5-question questionnaire. Hey, do you think the system is more reliable than it was last quarter? And that's an incredibly meaningful asset to have from within your organization. Now you go to the second, third, or fourth level, and you're going to get like a broader and more accurate view that gets closer to like what's the actual business impact of the money you're spending on people and resources in a reliability organization. But even on the first pass, like I would love to have that at some of the, for example, at a very large video streaming company that I worked at. I would have loved to have that data. What do the people responding to incidents think about the stability of the system this quarter versus the previous quarter? And I'll tell you, when I do chaos engineering consulting, the first thing I do is go to the engineering team and say, okay, which is the system that you're most afraid of? Right? What's the, and they always have one, whether it be like somebody's web server under a desk or like, a team that's all the way on the other side of the planet operating a system. There's always like something Redis that keeps people up at night, because if it goes down, it's going to create cascading failures. So I don't think I guess my answer is I don't think it's that hard to get started. We just don't have, and we don't talk about a lot of examples of ways to get started.
We don't have a culture that generally, right? Like
Yeah.
engineers want to look at numbers and they're used to looking at numbers and they're used to just taking that kind of telemetry in and making decisions off of it. But really, it's the stories that matter, right? It's asking the team which is the system that scares you the most is a heck of a lot more useful than looking at all the metrics that we collect from those systems and figuring out which one actually needs attention, right?
Yeah.
And we have this problem, um, even in product orgs, for example, right? Of wanting to send out surveys where people put in a number from 1 to 10 and, yes, no, somewhere. People generally just put 1 or 10 or 5, they rarely pick 7 or 8 is shown, like there's actually a lot of study that it's so much more useful to sit down with a person and ask them questions, right? There's so much out there proving that, just going and talking to people will give you a lot better data than the stuff you can kind of automate.
So one thing that's kind of been noted a couple of times is MTTR metrics like nines of uptime, nines of availability. It's a very easy number for non-engineers to grok. And SLOs, I mean, there's more complexity to them. So how do reliability engineers, how do engineers in IT in general socialize socialize reliability in a way that doesn't make executives or your board go, I don't get that. I understand a number of nines. That's very simple. I understand mean time to recovery. As noted, it's kind of it makes sense in your brain. So how do you start that conversation, and how do you package this up in a way that is grokkable by non-engineers?
I think it's incumbent on everybody who's in this field to start using qualitative methods. And if your executive team requires pretty dashboards, then add numbers to the qualitative data, right? You can put a mood score on the response from the frontline engineers or whatever. Turn it into a number if they're more comfortable with a number. But again, like then you're dealing with more valuable, rich data, and it's actually meaningful. Yeah, I mean, you raise number of nines. That's not the topic of this webinar, but equally problematic number. It's a distributed system. There's no way that you're measuring that accurately. Again, it doesn't correlate with severity, and anything over 4.5 nines of availability is bullshit for a consumer-facing service, because no customer has 5 nines of availability because of their ISP and Wi-Fi router.
And also, especially your change, they change of cycles on those too. That generates unreliability, right? You're updating the app every day or 10 times a day.
It's
I think
just not a good number.
Like differently, like I honestly I wish that we created better metrics and convince people to use better metrics. Like every metric requires a narrative. 5 nines doesn't mean anything in itself. Like you need a narrative. When you're looking at a dashboard, you need to know what good looks like. What is it, a range you want to hit? Is it a number you want to hit? Why is that number good? Is it bad when it goes down or up? Like from like what time scale are you looking at? Like a lot of things that go into metrics, and especially also balancing the metrics, right? When you're looking at a single measure, it's almost always a bad idea.
Yeah. This is, God, yes, I love everything said. And this is why I love SLOs, and they're only one potential step or solution to all this, right? But that's what they do if you're doing them right. You can also do SLOs entirely incorrectly, right? But if you're picking a good SLI is a measurement of your user happiness, essentially, right? And your SLO target is just the acknowledgement that things won't be perfect. And then your error budget produced out of that is a number that helps you think about how things have happened over time, and those are kind of abstract ways to put it, because in some situations maybe the 500 versus 200 responses from your simple web API does in fact tell you the correct story. But the point is you have to start from there, right? You have to start from, am I measuring what matters? Or no, one more step back. What matters? Then, am I measuring what matters? And then, how am I using that data?
That's I don't think we can emphasize that point enough. I have another example that for me really illustrates that well. I was consulted for a project, nameless furniture company, that wanted to spend millions of dollars setting up an AI system that would analyze what office furniture customers had bought, so that they could figure out what the room arrangements were, so that then they could suggest furniture that would also fit in those rooms. And that sounds like a lot of fun to as an engineer, I was like, oh, that would be really cool. But I had to ask them, why can't you just like go to your customers and ask what additional furniture they want? And it was like, oh, yeah, that would probably cost, a few $1,000s instead of millions, and it would actually give a more accurate answer. Like we can't overlook just going to the customers and asking what they actually care about. I have plenty of examples of large, complex distributed systems at scale where downtime isn't the thing that customers care about necessarily. So, chasing this number, this magic number, if we had one, wouldn't even provide the business value that we, are kind of assuming it would provide.
You don't understand. You could put AI on it instead of talking to actual humans. Come on.
Good point.
Humans are scary.
Yep, touche.
Humans are scary to talk to, but also they're the most important part of all this, right? It's all about the humans. And, like to tie it back a bit, that's why simplistic measurements like MTTR that do not take the human factor into account, right? Because it's the human factor that is part of why that's not a normalized curve. and why just looking at the P50 makes no sense. You know, it's you always got to make sure that you're taking the humans into account at any possible step in measurement.
Okay, so we've only got about 4 minutes left in this. Wanted to just kind of quickly go around. I'll just start
We
with.
actually we actually have a question from Sandra that I just really want to answer.
Oh,
It's
yes.
the question is it possible to use qualitative data to make faster decisions, like promoting a service to the next stage if X or Z? I would argue that that's already how most software works. The qualitative decision is made by an engineer who looks at the code and says like, oh yeah, that looks good. I feel good about promoting that to production, so I will. I am pretty sure that's still how most software works. It's entirely qualitative. I know, you know, I'm giggling because it feels wrong, but it's true. And most of the systems that we deal with in life actually work, right? We wouldn't be still using them if they didn't work. So that's a perfectly good qualitative measurement.
And, you know, even if we want to take it one step further, and now we're like, okay, we're talking about an automated canary based or A/B rollout, right? That has certain parameter sets, right? A certain number has to be reached. We released 5% of the fleet is now running version of code that, you know, like the new version of code, and we are analyzing the CPU usage and the memory usage to make sure there wasn't some big regression and all that kind of stuff. And we do all that in an automated fashion before we push out to the other 95% of the fleet. Well, you know, all those numbers were chosen by a human, right? So, like, all those individual measurements were still at some point, even if someone isn't looking at the code every single release in the way that Casey was describing, the way it's being released was still decided by a human in the first place. And there's some kind of contract, right? Like, there's some kind of agreement there amongst people about what good looks like, what should be allowed to continue to roll out. A human still did that.
I want to ask one last question that we've got in the Q&A. There's a couple more, and we can follow up with them via email. You can contact us, find us on LinkedIn, any of our great panelists, which is considering incidents independently, MTTR might reflect how well we identify, triage, and restore service. It reflects efficiency under duress, especially for novel incidents. And basically the question is, how do SLOs assist with reflecting how well we respond to problems in the moment? Ignore preemptive resilience engineering practices for this question, please.
I mean, is this me?
It's
a very long question, and we have 45 seconds. And I'll basically say that SLOs give you a better understanding over time of how the humans are able to respond to failures within complex systems. So in the moment, will an SLO tell you exactly how well your response was? No, but MTTR is also not going to answer how good your response was at any moment. This is another place where you got to be qualitative, and your learning from incidents approach needs to be human focused and needs to be about the narrative, and you need to go ask the people later. So does an SLO help you in the moment understand your response? No, but that's fine, because nothing does. You need to reflect on that later.
All right.
It's the quickest
That
way.
is, sorry, Alex, didn't mean to interrupt you. But that is our time today. I want to give huge thank yous to our panel, Sasha Chichovsky. I'm gonna just wreck that name differently every time I say it. VP of Technology at Ergonautic. Casey Rosenthal, the CEO and co-founder at Prowler. Dan Salinas, Noble Nine's CRO, and Mr. Alex Hidalgo, who wrote the book on SLOs.
We literally talked before the webinar that you don't pronounce the H.
Oh, yes. I'm, oh my God. So I'm just
This
here
is
butchering
good-natured
names
ribbing,
left and
everyone.
right.
This is
it's gonna be added to your KPIs to
Yeah.
pronounce Alex's name correctly.
Mean time to right name pronunciation.
Hey, thanks
So-
everyone. Like, this was a lot
Thank
of
you.
fun.
Thank you, everybody, for joining us, and have a wonderful rest of your Wednesday.
Take care.